Hello everyone, thank you very much for signing into my live stream. I'm Mr. Matt and this is Dr. Tot. Dr. Tot, cookie for class? Yes? Okay. And welcome to SAT, ACT Prep. I hope you all had a wonderful holiday break and we're going to get back into some review for the upcoming exam. We're going to do another miscellaneous practice set today, so we're going to look at pairs of questions, 3 pairs of questions that test similar topics so you get a wide range of exposure to the problem sets. And as always, if you have any questions, please post a comment below, or I'm always available on any of my social media accounts listed in the description. Let me go ahead and share my screen with you. And just a reminder, this is a live session, so there's a little bit of a delay with the iPad, but I'll try to mitigate that as much as possible by monitoring the live screen. And if you have any questions, again, just let me know. I'm going to give you 6 minutes after I read the question with you, and about 2 minutes into those 6 minutes, I'll start to solve to give you some hints. So question number 1, the ratio of blue to red to yellow to green marbles in a jar is 3 to 5 to 4 to 6. If there is a total of 1,800 marbles in the jar, what is the difference of the number of green marbles and the number of red marbles? Number 2 asks, a water tower is constructed using a concrete cylinder with a diameter of 20 feet and a height of 100 feet. If water is being poured into the tower at a rate of 200 cubic feet per hour, which of the following is closest to the number of minutes it will take to fill the water tower? So I'll give you 6 minutes, and again, 2 minutes in, I'll start to solve. Okay, so let's go through these. For number one, with ratio problems like this, when you know the result or the sum of the overall ratio, that you know the finite total of the items being described, you can approach this in either one of two ways. One, you can set up an equation representing the ratio elements as the coefficients in the variables, adding all of those monomials up and setting it equal to the total sum that they give you. Or you can evaluate these ratio elements convert them into fractions and evaluate those fractions against the total sum. So in the first option, if we know that the ratio is 3 to 5 to 4 to 6, I can say that 3 times some common multiple x plus 5 times some common multiple x plus 4 times that same common multiple x plus 6 times that same common multiple x has to be equal to the total number of marbles in the, a jar? In the jar of 1800. So 3x plus 5x plus 4x plus 6x is equal to 18x. So 18x is equal to 1800. Dividing by 18 on both sides, you'll find x is equal to 100. Now, x being equal to 100, that's not necessarily the answer. It turned out to be the answer here, but that's just coincidental. That's not always the case because x here represents the common multiple. In order to solve, the number of green marbles was represented by the monomial 6x. Whoops. Sorry about that. Let me get a different color here. It was represented by this monomial 6x, and the number of red marbles was represented by that monomial of 5x. They're asking ultimately for the difference between these two values. Difference implies subtraction, or the difference is the answer to a subtraction problem. So we need to subtract 5x, the number of red marbles, from 6x, the number of green marbles. 6x minus 5x is 1x. So the answer here that we're going to evaluate is 1x, which is just x, which happens to be the same value of the common multiple. But I don't want you to confuse the two. You do have to actually go back to the question they're asking and make sure that you are answering the correct thing. The second version here, we can understand that ratios are just comparisons of fractions that have the numerators of fractions that have the same denominator. So when they give us this ratio of 3 to 5 to 4 to 6, we can immediately determine what the common denominator is out of all of these individual fractions by simply adding up all the ratio elements. So you add up the ratio elements, 3 plus 5 plus 4 plus 6 is 18. The ratio element representing the green marbles was 6. So the green marbles, it has a ratio element of 6, but it's 6 out of 18, or 6/18 of the whole jar. So if we know the total number of marbles in the jar to be 1800, we can take 6/18 of 1800, and that's going to give us 600. We can do the same process for the red marbles. The red marbles were represented by a ratio element of 5. So the number, the fraction of the jar that is red, that are red marbles, I should say, is 5/18 of the entire jar. So 5/18 times 1800 will give you 500. 600 minus 500 is 100. So no matter which method you use, you'll get the same answer. Sometimes the questions can be written so one version is a little bit easier than the other, but mostly it's an individual personal preference as to which version students like. So you can pick which one, and if you have any questions, then please let me know. For number 2, you needed a formula. So you needed the volume of a cylinder. Any regular right prism, so any three-dimensional shape that has sides perpendicular to the base, any standard shape like a cylinder, a cube, a rectangular prism. In essence, all of their volume formulas are merely the area of the base times height. Because if you take the two-dimensional measure of the base, in a cylinder, the base is a circle, right? So if you take the area of the circle, right, which is pi r squared, Oh, excuse me, pi r squared. I gave you the wrong formula here. I'm so sorry. Pi r squared. So if you take the area of the base and extend it over height, then you're going to get the volume of the cylinder. So actually, let's go back, and since I did the wrong formula here by accident, I actually did surface area. Let's go back through this and check our answer. So if the volume of a cylinder is equal to pi r squared h, the radius here is 20 because they told us the diameter is 40. The radius has to be half of the diameter. So 40 divided by 2 would be 20. The height here is 100. So the volume is going to be pi times the radius, which is 20, squared times 100. 20 squared is 400, so this is going to be pi times 400 times 100. And so let's multiply that. Pi is approximately 3.14. So 3.14 times 400 times 100 is going to be 125,600. So these, I do apologize, these answer selections there are going to be off. So if we then take the rate, they say that the water is being poured into the tower at a rate of 250 cubic feet per hour. If we take the number of cubic feet that this water tower contains and divide it by the rate of 250 cubic feet per every 1 hour, let me continue this down here. This is the same thing as 225,600 cubic feet. We can write that as a fraction. When you divide a fraction by a fraction, you multiply by the reciprocal. So that means that we're going to flip that denominator around to 1 hour over 250 cubic feet. So you can see it's not apparent at first when you immediately divide because you have a rate in the denominator, but because you're dividing, that's the same thing as multiplying by the reciprocal. And when you do that, cubic feet will cancel with cubic feet. And then if I divide this by 250, then we're going to have 502.4 hours. Now remember though, that's in terms of hours. So you're going to have to multiply by 60 in order to convert that into minutes. So our answer here would be 30,144. So let me just add a 0 to all of these answers, and we'll say that the correct answer was C, approximately 30,000. If you have any questions, then please let me know. Otherwise, let's look at 3 and 4, and I suspect that those typers are going to continue for the next two problems, so I'm going to go ahead and solve this, and then I'll correct the answer selections to number 4. But go ahead, I'll give you 6 minutes, and please look at numbers 3 and 4. 3 asks, the ratio of blue to red to yellow to green marbles in a jar is 2 to 5 to 3 to 10. If there's a total of 4,400 marbles in the jar, what is the sum of the number of blue marbles and the number of yellow marbles? Number 4 asks, a water tower is constructed using a concrete cylinder with a diameter of 50 feet and a height of 120 feet. If water is being poured into the tower at a rate of 200 cubic feet per hour, which of the following is closest to the number of minutes it will take to fill the water tower? So for now, just answer number 4 as a grid-in, and I'll correct those answer selections in the first 2 minutes. Okay, 6 minutes, and then we'll go through the full explanation. Okay, so let's go through these two problems. For number 3, so we have two options. We can either write an equation because we know the total sum representing the ratio elements as the coefficients of the monomials, and then just solve for the common multiple, plug that multiple back in for the expressions that represent the individual values we're interested in, and then do whatever operation they are asking of us. So here they're asking us to sum the two numbers together of the blue marbles and the yellow marbles. So to write an equation, I would represent 2x plus 5x plus 3x plus 10x being equal to 4,400. Adding all of those x values up, we're going to get 20x is equal to 4,400. Dividing by 20 on both sides, the common multiple of x would be equal to 220. So that means that you can now evaluate each of those expressions that represent the individual values of the different colored marbles. Here we're interested only really in the blue and the yellow marbles. So that's this coefficient of 2, which we represented as 2x, and the coefficient of 3, which we represented as 3x. So substituting 220 in for x into those expressions, 2x would be equal to 2 times 220, which would be 440, and 3x would be 3 times 220, which would be 660. Now we could also convert these ratio elements into fractions, recognizing that the denominator is the sum of all the ratio elements in the ratio. So if you add up all of the elements in the ratio, 2 plus 5 plus 3 plus 10, you get 20. So the blue marbles are 2/20ths of the whole jar, and the yellow marbles represent 3/20ths of the whole jar. Evaluating these fractions against the whole number of marbles in the jar, 4,400, we're going to find that 2/20ths times 4,400 is going to be 440. 3/20ths times 4,400 is going to be 660. So we get the same values no matter which method we use. And then when they're asking ultimately for the sum, so 440 plus 660 is going to be 1,100. Answer selection D. So I needed to add a 0 to all of the answer selections in number 4, but if we calculate the volume of the initial water tower, we're going to use the formula pi r squared times h. So the area of the base, which is a circle, pi r squared, extended over the height of the cylinder, which is h. They say that the diameter of the cylinder is 50 feet, so therefore the radius has to be 25, and they give us the area as being 120 feet. So substituting those values, we're going to get pi times 25 squared times 120, which is going to give us 235,500 cubic feet of volume. If we take the volume of that water tower and divide it, you can either think of it as dividing by the rate, but maybe a more easy way of thinking about it, a more convenient way of thinking about it, is to understand, excuse me one second, it's to understand that rates can be flipped around. You can think about the rate as either being 200 cubic feet every 1 hour, or you can think about it as 1 hour for every 200 cubic feet. It doesn't matter which item you place in the numerator or denominator, other than making it a little bit more logically relevant to a particular context or a particular problem that you're solving. Here, if I take the given volume of 235,500 cubic feet, and that's not a fraction, but I can write it as a fraction by just putting it under 1. Notice that if I ultimately want the number of hours it takes, the time period, I want to end up with an answer that has a time unit. So if I multiply by the rate of 1 hour for every 200 cubic feet, not the given format that they use in the problem, where they say 200 cubic feet per hour. Notice here I'm flipping that around, because ultimately I want to cancel out cubic feet with cubic feet. Because when I do that, then I'll be left with an answer in terms of just hours, which is not exactly what they asked for, because they actually asked for minutes, but at least it's a time unit. If I didn't multiply in that fashion, if I left it in the format of 200 cubic feet over 1 hour, I would end up with a really, really strange answer, at least an answer with some very strange units. I would have cubic feet times cubic feet. That would be feet raised to the 6th power, which is beyond our spatial dimensions. That's like extra dimensional. So that makes no sense. It would be feet raised to the 6th power over hours, or per hour, which doesn't make any sense. So that's a clue. If you keep the units attached to your problem while you're doing these types of dimensional analysis problems, exercises, then at the end you can check to make sure you did the right process as to whether your units make sense given the context of the problem. So here we cancel out cubic feet and we're left with hours. That's all good because they ask us about how long it takes to fill the water tower. However, they ask us how many minutes, and we just solve for the number of hours. So the quick version is to just multiply by 60, but I'll show you why, and it's the same process as we did initially. So if we have 1,177.5 hours, I'm going to take that given amount and I'm going to write it as a fraction by just putting it over 1. If I multiply by some conversion factor, meaning that I want to go from hours to minutes, well, I have hours in the numerator, so I have to get rid of that by putting hours in the denominator. I know that 60 minutes is equivalent to 1 hour. So by setting up a fraction like this, you're actually writing a value of 1 in different units. 60 minutes is the same thing as 1 hour. They're just different units. Something divided by itself is 1. 1 times anything is that same something. So it's not changing the actual value here, the actual amount of time. It's just converting between equivalent units. So when I do this, hours will cancel with hours. Hours in the numerator will cancel with hours in the denominator. And that will leave us with 1,177.5 times 60 times minutes. Actually, let me use parentheses so it's not so confusing. And this is all in terms of minutes now, divided by technically 1 times 1, but that doesn't have any effect. 1,177.5 times 60 is going to be 70,650 minutes. And that is closest to the answer selection of 70,000 minutes. And that's answer selection C. If you have any questions, then please let me know. Otherwise, let's continue. So last pair of these 2 questions. Number 5, the ratio of blue to red to yellow to green marbles in a jar is 1 to 3 to 2 to 4. If there's a total of 1,600 marbles in the jar, what is the difference of the number of green marbles and the number of red marbles? Question 6, a water tower is constructed using a concrete cylinder with a diameter of 60 feet and a height of 150 feet. If water is being poured into the tower at a rate of 525 cubic feet per hour, which of the following is closest to the number of minutes it will take to fill the water tower? And again, I'm going to correct the answer selections to number 6 in the first 2 minutes, but go ahead and take 6 minutes to solve. After 2 minutes, I'll start to solve as well to give you some hints. Okay, so let's look at 5 and 6. So again, we can use either of the two methods, either writing an equation or converting the ratio elements into fractions and evaluating those fractions against the total whole. If we wrote an equation, then we would say that 1x plus 3x plus 2x plus 4x is equal to the total number of marbles in the jar, which is 1,600. Combining like terms, you'll find 10x is equal to 1,600. So x, the common multiple, has to be equal to 160. If you substitute that common multiple into the expressions that represent the individual values for the green marbles and the red marbles, respectively, which were 4x and 3x, 4x would be 4 times 160, which is 640. 3x would be 3 times 160, which would be 480. 640 minus 480 is 160. And again, the answer here was only the same as the common multiple, only because the expression that we were evaluating was 1x. At the end of the operation, when we took the difference, which is subtraction, we ended up basically with an expression representing 1x of the common multiple. That's not always going to be the case, so make sure that you don't just stop after solving for x. You have to plug back in to evaluate for the individual numbers, depending on whatever it is in the problem. Or we could convert these ratio elements into fractions. Remember that a ratio represents a comparison of numerators that share the same denominator. The denominator is going to be the sum of the ratio elements in the ratio. So 1 plus 3 plus 2 plus 4 is 10. So green marbles represent 4/10 of the total jar. 4/10 of 1,600 is 640. The red marbles represent 3/10 of the whole jar. 3/10 of 1,600 is 480. Again, when we subtract, 640 minus 480 is going to give us 160. For number 6, I apologize. I changed all the answers and then I left off a 0. So they were supposed to be 40,000, 50,000, 60,000, and 70,000. But hopefully you just went ahead and solved as a grid-in, so I do apologize in advance. So here we need to solve for the initial volume of this water tower to see how much space we need to actually fill. The formula for the volume of a cylinder is pi r squared h. Radius here is half of the diameter. The diameter is 60, so the radius has to be 30. They give us the height as being 150. So substituting those values in, we're going to get pi times 30 squared times 150, which is going to evaluate into 423,900. Let me just check that because that's a really round number now that I'm looking at it. And pi is not a round number, but actually I approximated, so that could be okay. Yep, that's okay. So I used 3.14 rather than the entire pi button, but to be most exact, you should use the pi button. So if we have a total of 423,900 cubic feet of water to put into this tower, I'm going to multiply it by a rate in a manner that's going to eliminate the units that I do not want and leave or convert into a unit that I do want. So the given unit right now is cubic feet, but in my rate I have cubic feet per hour. I don't want hour because they're asking me about minutes. So when I convert, ultimately I want to get rid of the cubic feet in order to get into a time unit. So when I take 423,900 cubic feet, I'm going to multiply it by the original rate inverted or flipped around, because remember that these two sides of the ratio have to be equal to each other. You can think of it as the rate being 525 cubic feet per every 1 hour, or you can think about the rate as being 1 hour per, or the amount of time would be 1 hour for every 525 cubic feet of water that comes out of whatever faucet we're using. So you can think of rates in either way. You can flip them around, in other words. So I do want to flip it around here, so then I can cancel cubic feet with cubic feet, essentially doing the same thing as just dividing by 525. But in order to know that that's what you should be doing, you need to keep the units attached so you know that the result checks out. Cubic feet cancels with cubic feet, leaving me with 807.4 hours. But again, those are hours, so I'm going to have to multiply by 60 to get 48,445.7 minutes. And that's closest if we round up, because it's greater than 45,000, we would round up to the next 10,000 multiple of 50,000. So the answer here should be B, 50,000. If you have any questions, then please let me know. Otherwise, let's move on to 7 and 8. These are new questions now. So number 7 asks, line M and line N intersect to create two pairs of congruent angles. If one pair of angles each measure 40 degrees, what is the measure of each of the other angles? So we're talking about the individual measure here, not combined. And question number 8, one year Mark bought 3 birthday presents for his friend: a balloon, a box of candy, and a baseball bat. If the box of candy is twice as expensive as the balloon, and the baseball bat is 5 times as expensive as the balloon and box of candy combined, how much did the balloon cost if Mark spent $36? So I'll give you 6 minutes. 2 minutes in, I'll start to solve. Okay, so let's look at 7 and 8. So for 7, anytime that two straight lines intersect, they create two pairs of what's called vertical angles. Now the name vertical can be a little bit misleading because it doesn't mean that they're going up and down. It just means that they're across from each other. Vertical angles are always congruent. So if each of the two, if they're talking about one pair, each being 40 degrees in measure, then I listed those here, and I'll outline them. So these two green angles are 40 degrees. We don't know what the other two angles are, but we know that they have to be congruent because they make up the other pair of vertical angles when two straight lines intersect. And in total, these make up, all four of these angles have to equal 360 degrees because they encompass the total number of degrees in a circle. They go all around the nexus of this intersection. So we know that 40 degrees plus 40 degrees plus x degrees has to be equal to 360 degrees. Adding 40 plus 40, we get 80. X plus x is 2x. Subtracting 80 on both sides, we're going to get 2x is equal to 280. And then dividing by 2, we're going to get x is equal to 140. So each of the other angles has to have a measure of 140 degrees, which is answer selection D. For 8, we need to first represent, because for number 8, the limitation here is that we can only write one equation, because I only have one explicit, i.e. numerical value. Well, that is the sum of the total bill, right? So we know that in total he spent $36. So I have to be able to represent some of these other unknown values in terms of the first or fundamental or primary unknown value. They represent all of the prices of the box of candy and the baseball bat in terms of the balloon's price, or at least the balloon's price or the box of candy's price. So if we first pick x, or define our unknown x to be equal to the cost of the balloon, and they say that the box of candy is twice as expensive as the balloon, then if x is equal to the cost of the balloon, 2x has to be equal to the cost of the box of candy. Then they say that the baseball bat is 5 times as expensive as the balloon and box of candy combined. Okay, so it's not just one. So you have to take the price of the balloon, which is x, plus the price of candy, or the box of candy, which is 2x. X plus 2x is 3x. They say that the baseball bat is 5 times as expensive as $3x. 5 times 3x would be 15x. So if I add up all of these expressions, x plus 2x plus 15x, I'm going to get 18x. So 18x, 18 times this common multiple of x, is equal to the total number of dollars spent, which is 36. So if I divide by 18, I'm going to find that x is equal to 2. Now they ultimately asked for how much did the balloon cost. The balloon has a cost expression of just x. So again, there's a coincidence here that the value of x is actually the answer, but you always need to go back. I could have asked you for what how much the candy costs, or how much the baseball bat costs, which I will in the next few questions. So it's not always going to be just x, and that's a real common pitfall for a lot of students. They work really hard and tediously in getting every line correct in this multi-step question, and they get really excited once you finally get that answer for x, but you always need to make sure you go back and interpret x in light of the context of the question. Are they actually asking you for what x is, or is x just merely a key of finally answering the last step in this rather long problem? Okay, so the answer to 7 was D, answer to 8 was A. Let's look at 2 more pairs of these examples, so 9 and 10. 9 asks, line M and line N intersect to create 2 pairs of congruent angles. If one pair of angles each measure 96 degrees, what is the measure of each of the other angles? And question 10, one year Rakeem bought 3 birthday presents for his friend, a card, an action figure, and a football jersey. If the action figure is 3 times as expensive as the card, and the football jersey is 6 times as expensive as the card and action figure combined, how much did the action figure cost if Rakeem spent $112? So I'll give you 6 minutes, and after 2 minutes, I'll start to solve. Okay, so let's look at 9 and 10. For 9, we have, again, two straight lines intersecting to create two pairs of congruent angles called vertical pairs or vertical angles. If we know that one pair each have measures of 96 degrees, then we know that the other pair, we don't know the measure, but we can represent them with the same variable because we know they have to be congruent to each other. So we can set up a total sum equation as 96 degrees plus 96 degrees plus x degrees has to be equal to the total number of degrees around the nexus of that intersection, which is the total number of degrees in a circle, which is 360. 96 plus 96 is 192. X plus x is 2x, so we get 192 plus 2x is equal to 360. Subtracting 192 on both sides, you're going to get 2x is equal to 168. Dividing 168 by 2, you're going to find that the other two angles have to have a measure of 84 degrees. So the answer to number 9 was D. For 10, if we pick the card to be the foundational kind of unit here, in which we compare all the other costs to the cost of the card, by letting the card's cost be equal to x, if the action figure's cost is 3 times the card, then its cost would have to be 3x. If the football jersey's cost is 6 times the combined cost of the card and the action figure, then we need to combine the cost of the action figure and the card. 3x plus x, or x plus 3x, the order doesn't matter, is going to be 4x. 4x times 6, because it's 6 times more expensive, is going to be 24x. So x plus 3x plus 24x has to be equal to the total sum of the amount of money he spent, which is $112. X plus 3x plus 24x is going to be 28x. So we get 28x is equal to 112. Dividing by 28, you're going to find x is equal to 4. Now notice here that is not the answer because they don't ask you for the cost of the card. If they did, then 4 would be the answer and it would be the same as the common multiple here of x. But to demonstrate this, it's not the same. They asked you for the cost of the action figure, which is represented by the monomial 3x. It had a cost of $3x. So now we know the value of x, it's 4. So you can substitute that in to the variable x in the expression 3x to find 3 times 4 being equal to 12. So the answer to number 10 was B. If you have any questions, please let me know. Last 2 problems, and then that'll take us up to the end of class today. Number 11 asks, line M and line N intersect to create 2 pairs of congruent angles. If one pair of angles each measure 130 degrees, what is the measure of each of the other angles? Number 12 asks, one year Daniela bought 3 birthday presents for her friend, a movie ticket, a pair of shoes, and a new winter jacket. If the pair of shoes is 5 times as expensive as the movie ticket, and the winter jacket is 10 times as expensive as the movie ticket and the pair of shoes combined, how much did the winter jacket cost if Daniela spent $528? I'll give you 6 minutes. 2 minutes in, I'll start to solve. Okay, so last two problems for number 11. If one pair of the angles each measure 130 degrees, then we know that two of them have measures of 130 degrees and the other two have to be congruent, so we can use the same variable to represent their angular measure. So we can say that 130 plus 130 plus x degrees has to be equal to 360. 130 plus 130 is 260. X plus x is 2x, so we get 260 plus 2x is equal to 360. Subtracting 260 on both sides, 360 minus 260 is 100, so we get 2x is equal to 100. Dividing by 2, x is equal to 50. For number 12, all of the pair of shoes and the winter jacket are all component costs or relative to the cost of the movie ticket. So let's define x, our unknown variable, to be equal to the cost of the movie ticket. If the pair of shoes is 5 times as expensive as the movie ticket, and the movie ticket is x dollars, then the pair of shoes would have to be 5x dollars. Then they say that the winter coat is 10 times more expensive than the movie ticket and shoes combined. So if we add the cost of the movie ticket, x dollars, plus the cost of the pair of shoes, which is 5x dollars, x plus 5x is 6x, and then we're going to multiply that sum by 10 because the winter jacket is 10 times as expensive as the movie ticket cost plus the shoe cost. So 10 times 6x is going to be 60x dollars. If we combine these ratios together, or if we write an equation representing each of these components, summing each of these components to a total cost of $528, we can write the equation x plus 5x plus 6x is equal to 528. X, which is really 1x plus 5x plus 6x is going to give you 66x. 528 divided by 66 is going to be 8. Now notice 8 is not the answer here because they ask us not for the cost of the movie ticket, which is just x, but for the cost of the winter jacket, which is 60x. So we need to substitute 8, which is the value of x, in for the variable x in the expression 60x. 60 times 8 is going to be 480. So the answer to number 12 is B, 480. As always, if you have any questions at all, then please let me know either in the comment section below, or you can contact me on any of my social media accounts. It's wonderful to be in contact with you guys again. I hope you all had a wonderful holiday break. And Dr. Todd, you want to say bye to everybody? Come on, let's say bye. Up. Come on. Come on. You can do it. Come on. Come on. Can you get up? Can you say bye? Can you say bye? That's a tongue. Can you say bye? Bye. Okay. There you go. Kind of half, kind of there. We're getting better. All right. Thank you guys very much for signing in. I hope you have a wonderful night, and I will talk to you all tomorrow.